This is the Pre-Calculus Fall Final Exam Review Part 2, pages 3 and 4 of the review. Number 14, sketch a quick graph of the following in radians. Well, just going to do a quick thumbnail. Sine starts in the middle and goes high. Cosine starts high and ends high. Tangent looks like this. It's an increasing function. Cotangent is a decreasing function. Cosecant's reciprocal is sine, so we graph sine starting in the middle and goes up and down, and then cosecant is the little U-shapes or horseshoes in honor of our mascot is a Mustang. And for cosecant's reciprocal is cosine, secant's reciprocal is sine, so it looks like this. And the b value is 360 divided by the period, which is 360 divided by 45. Oops, the period's in radians, so that would be 2 pi divided by 40, which is pi over 20. I'm not sure I had the record going on for all of this, but the period is from here to here, which was 40. The total vertical distance was 70. Half of that is the amplitude of 35. Horizontal shift of left 7. Vertical shift of down 10. And then we've got the b value, which is pi over 20. So the formula is y equals k plus a, the trig, b, and then I really need to learn how to write smaller, x minus h. So it's y equals, shifted down, negative 10, down 10, negative 10. We did a positive cosine, so it's plus 35. Positive sine, shrink again, and shift, open parenthesis x, and we're shifting left, that's positive 7. Okay, 16 and 17 are convert these degrees. 16 is convert degrees to radians, and 17 is convert radians to degree values. We use one of these two identities, pi over 180 or 180 over pi. If you're converting 2 radians, you're adding pi into the mix, so you use this one. If you're converting to degrees, you're dividing through by pi. So we start with 16a, 45 times, we're converting to radians, so it's going to be pi over 1 80. That equals pi over 4. Okay, so for B, the answer is 2 pi over 3. C is 5 pi over 6. D is 5 pi over 4. And E is a negative pi over 2. Trick when you put these into, since we're using calculators, when you enter it into the calculator, the trick is to not put in pi into the calculator, and then use math fractions to get the fraction, and then write the pi back in. For converting from degrees to radians, you can put the pi in, but you're going to put the pi in the numerator and the pi in the denominator, and that's just a waste of time. You can, so for in the calculator for number 17, remember fraction mode. If you have one of the yellow calculators or the calculator using the right version of the software, it's alpha y equals enter to get fraction mode. You get a box over a box in the calculator. It's very useful. If you do not have that, come to Mr. Clausing's room in B103 and I will upgrade the software on your calculator to have that feature. Alpha y equals enter. But put in your calculator, put in the 4, this is for A, 4 over 3 times, and we're going to convert it to radians, so it's going to be multiply it by 180. What you're leaving out of the calculator is you're putting a pi here and a pi there. Those are going to cancel out. 3 goes into 180. 60 times 4 is 240 degrees. So can I erase this? For once I can. This is for A, it's 240 degrees. For B, it is 30 degrees. For C, it's 315 degrees. For D, it is 150 degrees. And for E, it's a negative 72 degrees. For 16 and 17, it didn't matter whether your calculator was in degree mode or in radian mode, but it absolutely does in 18. It says find the exact value of pi over 3. So we can do that the old-fashioned way. That is this triangle where this is 1, square root of 3, 2. Sine is opposite over hypotenuse. The opposite is square root of 3. The hypotenuse is 2. But most of you are going to do that in the calculator. This is the exam is a multiple choice test, so you would have to evaluate this rad 3 over 2, finding the decimal and getting the decimal value out of the calculator and converting your answer choices to be the decimal equivalent. So we'll just give you the answers. These are in non-decimal form. This is a rad 3 over 2. Tangent to pi is 0. Cosine of 3 pi over 2 is a negative 1 over rad 2. Cosine negative of a negative pi over 6 is a positive rad 3 over 2. Okay. Check those values in your calculator. Make sure if you use your calculator, you are converting this answer choice or your answer to a decimal. Okay. Okay, let's see if I can erase these. I can for a change. Clean this space up. Okay, 19. If x equals cosine inverse of 0.7, then what does x equal in radians? Okay, so x is going to equal a 0.795. Check that in your calculator. Remember, you had this button, so use it. If you don't, if it was a problem like secant inverse of 1.2, that would equal cosine inverse of 1 over 1.2. The flag never goes to the bottom, but whenever you don't have a key, you end up creating a fraction. Okay, this is page 4. Alright, again, I'm going to assume that you're going to be using a calculator to solve these and finding the exact principal value. The calculator will do it. Remember, sine positive is in quadrant 1, but you're going to plug this in, and it's theta, so it's in degree mode, and it tells you in degree mode. So sine inverse of 1 is right 90 degrees. Excuse me. Cosine inverse of a negative rad 3 over 2. That's in quadrant 2. That's 150 degrees. Remember, I'm putting these into the calculator. Now, you need to watch out for something like C if you're just going to blindly use your calculator. Okay. The calculator is going to say error domain, quit or go to, and go to is not going to tell you much, except it's going to take you to the number and tell you that 2 is outside of the domain, or excuse me, outside of the range, because remember, cosine is sine is opposite over hypotenuse, which would be 2 over 1, and look, your hypotenuse is less than the opposite, so this is a no solution. Okay, your calculator is going to tell you error domain. You're going to have to interpret that or know to go further and to look at this problem and see why the calculator can't solve this, because it's outside of the range of sine. Remember, sine goes from up to a positive 1 to a negative 1. Okay, so it's outside of the function's range, so thus no solution. Okay, switching to 21, we're going to find the exact value in radians. So remember to go to your calculator. That's another thing. If you get an error or something, check your mode. Make sure you're in the proper mode, because it's easy to give it a bad number if it's in the wrong mode. Okay, so remember, arc sine is sine inverse. So we can go through this. This is going to be a negative pi over 4, a pi over 4, and 0. And again, you'll have to remember to change your answer, multiple choice answers, into in terms of pi, or convert your answer choices into decimals to be able to get the correct answer. You can do the same things for 22. Sine inverse of cosine of this. This is going to be a negative pi over 3, a rad 7, over 4, and again, this one is a no solution, because we're going to find the the adjacent or the hypotenuse is the adjacent is greater than the hypotenuse, or the okay. For 22, given this, okay, you're going to plug this into the calculator again in degree mode, in radian mode, and you're going to graph this, and you're going to find that f of 8 is 4.298, and the first three positive values remember, we got to graph this. You're going to have to change your calculator's window so you can see enough of this. You're going to plug in, for A, you're going to plug in 8 into the table. Remember, you can do table setup and change independent from auto to ask and type 8 in. You do that if it was 8.2, for example, and then find the first three positive values. You plug this into y1, you plug this one into y2. In fact, we were putting this one into y1 and putting this one into y2, so that way you would get the intersections. Go find the intersection that you're looking at, make sure this is the first positive value, the second one, and the third one, and find the intersections. Remember to round off correctly. You hover over the answer, and this first one was 0.825. Notice it's positive. 11.175 and 18.825. Okay. For the second one, you do the same thing. Remember this, put in for y1 equals 2, and y2, put in this function. Remember, it's in radian mode. F of 1 equals 6.035, and the first three positive values are 5.239, 10.761, and 29.239. Okay. This ends page 4 and ends part 2 of the review.